Alright everybody, this is the super fancy presentation over a little thing called inflation. So we've talked about unemployment, we've talked about GDP, this is another macro measure, so how we're measuring what's going on in the economy. Now inflation, as you know, is going to be when prices rise, and when prices rise, that means the value of the money is going down. Alright? Yeah, it's a pretty simple concept to think about, right? So if the prices are going up, your money won't go as far as what it did before. So let's say that you spent $100 on something in 1 year, all right? And the next year, you have to spend $105 to get the exact same stuff. The value of the stuff didn't change, right? So it's the same stuff as what it was before. What changed was the amount of money that was required in order to buy the same stuff. All right, so we call this inflation. Prices rise, value of the money goes down. Why it happens? There are various reasons. It kind of depends on who you ask. One of the biggest factors is going to be how much money is out there in circulation. The more money there is in circulation, that tends to raise prices. You think at a base level it's just because, more money, and therefore people are going to, it's not worth as much. That in itself is the issue, and it's related, but there's more factors that go into it than that. But we'll get that at another point in time. All right, so we're also measuring the cost of living, right? So when you had to spend $105 to buy the same stuff that $100 before bought you, what that means is that your cost of living is going up. You have to use more dollars to maintain the same standard of living as what you had previously. So in order to buy everything that you had before, more dollars are required. All right. Now, some of the notation we'll use, inflation is the concept, right? And we're going to note this with pi. Different texts and different sources will use different notation, different symbols. Pi is one of the standard ones, so that is what we will use. All right. So pi is related to inflation itself. The inflation rate is pi%. So inflation is the idea that prices are rising. Inflation rate is actually the measurement by which prices are rising. So it is the percentage by which the prices are going up from 1 year to another one. So in our case of the prices went from, for stuff, from $100 to $105, we would say that was a 5% inflation rate, right? Because you needed $5 more out of 100, so that'd be 5% more dollars in order to buy the same stuff, all right? So that would be a 5% inflation rate. So what we had was inflation and a 5% inflation rate. All right, the measurement of that talks about what the inflation actually was. All right. Now, there are different ways of measuring inflation because if we're going to say that inflation rate is looking at the change in prices from one time period to the next, the question then is, which prices do we look at? There are lots of prices out there. And one of the biggest ones that we use is called the CPI, the Consumer Price Index. Okay, and there are different price indexes out there that analyze different prices within the economy. The CPI looks at what the typical consumer buys. All right, so the overall cost of goods and services bought by a typical consumer. And the way you look at this is you have this agency in the federal government. It's called the BLS, the Bureau of Labor Statistics, and they measure all sorts of stuff. They're the ones that measure the unemployment rate and other things, right? But one of the big things they also compile is going to be the CPI, Consumer Price Index. And what the BLS does is that every month they will send surveys out to businesses and to consumers and ask them about prices and what they're buying and stuff like that, all right? The basic idea here with finding the CPI, or any price index for that matter, but the CPI specifically, is think of it this way. The BLS goes to Consumer Mart, and at Consumer Mart, they go down the aisles and they buy the things the typical consumer is going to buy. So they grab housing, and they grab medical, and they grab transportation, and they all put it into their basket, all right? So they all put this into their basket, and they look at what the prices are for each one of these as they put it into the basket, and then they go to the checkout, and they check out and see what the total is for all the stuff they put in the basket. All right? So the next month, BLS goes back to Consumer Mart and they go down the aisles and they put all the exact same items into the basket as what they did previously. But they see what the prices on all those items are this time, and then they check out and see what it costs to buy all that stuff this time in this month. And if it's the exact same stuff, and it is, it's all the same stuff in the market basket that they put in, they look at the change in the total price, total checkout price from one month to the next. All right. So like in our previous scenario, if it cost them $100 to buy everything in 1 month, and then the next month it cost them $105 to buy all the same stuff, that would mean that there was 5% inflation that occurred from one month to the next. They're buying all the same things, but the prices have changed. They've gone up. It costs more money to buy the same stuff as what we did before. So therefore, you have inflation. All right. So this is what the BLS does: is analyze the CPI and build up the CPI through all these surveys and market baskets. All right. So you can monitor the changes in the cost of living over time. All right. So if CPI rises, this price index rises, that means you have to spend more dollars to maintain the same standard of living as you did before, like we mentioned. Now, how they calculate this? Well, you fix the basket. What this means is you determine what you're going to put into the basket. So this is the BLS going down the aisles and putting things in the basket. Well, they need to decide what they're going to put in the basket. So what are they going to put in for transportation, medical, and housing, and food, blah, blah, blah. All right, so you fix the basket, fix the goods that are going to be in the basket. Okay, so this is what they do through all their surveys and whatnot. Now, things in the market basket do change over time, but they don't replace things very often or very quickly, because if you do that, then the CPI is not going to be a useful basis for comparison. Right? If you're always changing what goes into the market basket, then you can't use it for proper comparison from one period to another, right? So you have to keep relatively the same things in there from time to time. Now, again, that doesn't mean that they don't change things in there. I don't know, CDs, music CDs may have been something that was counted in the BLS at one point in time. Obviously, it wouldn't make any sense to put it in there now. At one point, cell phones, I'm sure, were never in there, and now they're probably in there, or cell phone service, right? So they do change stuff over time, but just not that rapidly. All right, so you fix the basket, you decide what is going to go into the basket, and then you find the prices. So BLS has gone down the aisles, they decided what they're going to put into the basket, and then they look at the prices on the shelves and see what each one of these things is going to cost. And then they compute the market basket's cost. So this is where they do the checkout, right? So everything that they bought and knowing what the prices are, they are able to compute how much everything in the market basket cost overall in total. Okay? So in order to find the price index, you have yourself a base year. A base year is going to be the year against which you compare all the other years. All right? So let's say we're going to use 2015 as our base year. So we're going to look at what the market basket was in that base year, all right? And then every other year will be compared against what it was for that base year in 2015. So if we're going to be analyzing 2018, we'll compare it against what things were in 2015. If we're going to analyze what things were in 2005, okay, we will compare against that base year of 2015, all right? Now, the way we calculate this is you designate this 1 year against which you judge all the comparison years, compute the index by dividing the price of the basket in 1 year by the price of the basket in the base year and multiplying by 100, all right? So here we got, somewhere here. See, this is where I wish I had a board. Oh, goodness. Let me see if I can type on this thing or I can figure it out. Frustrating. Hold on. Alright, so I'm back. I think I solved the issue, kind of, sort of. So this is the slide that we're on. Alright, I just made myself a new slide. Alright, so calculating the price index looks a little like this. You have the market basket in the comparison year, whatever it costs for that comparison year, divided by the market basket in the base year times 100. Alright? So let us say that we're talking about the base year, all right? Let's say that the market basket was I'll try to use some easy numbers here. Let's say that it was $1,000 in that base year. Well, what is the price index for that base year? Well, the base year is also your comparison year in this case. So it'd be $1,000 divided by $1,000, which gives you 1, times 100, which will give you a price index of 100. Okay, and this is worth noting. The price index in the base year will always be 100. All right, I'll say it again. Price index in the base year will always be 100 because it's going to be the same number over the same number times 100. Okay. Now let's say that in the comparison year, the price index was, or excuse me, not the price index, the market basket was $1,100. All right, so you have $1,100, okay, divided by 1,000. Okay, $1,100 divided by 1,000. If you want to, you can get yourself a calculator and verify this yourself. All right, so you got 1,100 divided by the market basket in the base year, which was 1,000. So 1,100 divided by 1,000 will give you 1.1. All right, so you have 1.1 times 100, which gives you 110. All right, so that would mean the price index in the comparison year, the CPI in the comparison year, is 110. All right, so in the base year was 100, and in the comparison year, it is going to be 110. All right. Now, why we do these price indexes, by the way, is they gives us an easy way to compare from one year to another one. All right. The way we did it here, right, is so if the original price index was 100 and the new price index is 110, another way of looking at that is that there was 10% increase, 10% inflation from one year to the next, right? We're saying that whatever cost $100 in your base year would have cost $110 in the comparison year. Right? Now, I used easy numbers there, it would obviously make sense. But let's say we had weird numbers, right, where we said something like the market basket for the base year is going to be something like, I'm going to write this down so I don't remember the numbers. It was 586, and then the market basket in your comparison year was 723. All right. Okay, smart guy. Tell me what the inflation rate is now. Okay, well, the price index, we're going to use that. For the base year, we know that is going to be 100, right? So it'd be 586 divided by 586 gives you 1 times 100, so price index of 100. All right, what's the price index for the comparison year? Well, I said it was $723, so the market basket was $723 in your comparison year. So it'd be 723 divided by 586, which is the market basket in the base year. And that would give you 1.23 times 100, so you'd have a price index now of 123. Tell me what the inflation rate was. 23%, right? We went from 100 to 123, so there was a 23% inflation rate, right? Anything that costs $100 in our base year would have cost $123 in the comparison year. See how this works now? All right, so we're creating a nice little base number here that we're able to work with. Okay, and you can go backwards also. You could wind up having price indexes that were smaller than 100, right? So if you're talking about an earlier year, typically. So the inflation rate is going to be the difference here between the price indexes, right? So the percent change between the price indexes from one year to the next one shows you the percentage by which the inflation has occurred. Okay, so the inflation rate, that calculation, so your comparison year, we'll say year 2 would be CPI in year 2 minus CPI in year 1 divided by CPI in year 1 times 100. Now, that all seems complicated. You can write that down if you want to. That is nothing more than a percent change formula. This is the same formula you would use for any percent change. It's basically new number minus old number divided by old number times 100. All right? So in the case of that example I just used, right, where we said the price index was 123 in the new year. All right, comparison year, so it'd be 123 minus 100. That gives you 23 divided by the price index in the base year, which was 100, gives you 0.23 times 100 to percentilize it, would give you 23%, right? So if you're starting off with a base year of 100, then it's easy to work with, right? But if you wind up with a weird price indexes, right? So if you're talking about a year where the price index was, I don't know, 88, and another one where the price index was 126, right? And the base year was somewhere in between, but we're comparing two other years other than the base year, then this would be the formula you would use, right? So it's just percent change, right? So new number minus old number divided by old number, right? Nothing special there. So here's an example to work our way through this. And there could wind up being questions to do this sort of thing. So let's say that in our particular society, this is the goods that get sold. We have 4 hot dogs and 2 hamburgers. So we're going to determine CPI and price indexes based upon this market economy. So we have fixed our market basket. We have 4 hot dogs and 2 hamburgers. All right. And now what we want to do is do the second step, which is doing the price, figuring out what the prices are for each one of the years. So we've got 3 different years here, 2001, 2002, and 2003. In 2001, hot dogs were $1 a dog, and hamburgers were $2. And then you look at the prices for 2002 and 2003. So they're going up by $1 in each year. Right? In 2002, they were $2 for a dog and $3 for a hamburger. 2003, $3 for a hot dog and $4 for a hamburger. All right. Yep. So the next thing is to compute what the market basket cost for each year. In 2001, we had 4 hot dogs. You'll notice there's 4 hot dogs and 2 hamburgers in each year, right? In 2001, $1 per hot dog was the price. So 4 hot dogs, you got $4 there. Hamburgers, 2 of those, and $2 per hamburger. So you got $4 there. The market basket was $8 total. Okay, in 2002, $2 per hot dog for 4, that was 8. $3 per hamburger for 2 hamburgers, that's 6. So you have a total market basket of 14. 2003, $3 per hot dog for 4 hot dogs, that's $12. Oh, and then $4 per hamburger for 2 hamburgers, that's $8. So you have a total market basket in 2003 of $20. All right. So we went from $8 to $14 for $20 by the exact same stuff at each step in each year. Okay. So now we need to figure out what are the price indexes for each year. If we're going to use 2001 as our base year, we already know the price index is 100, right? So $8 divided by $8 times 100 gives us 100. In 2002, the price index, or excuse me, the market basket was $14. We divided by the market basket in the base year of $8, and then we multiply by 100. So 14 divided by 8 is 1.75. Times 100, price index of 175. In 2003, the market basket was $20. We divide that by the market basket in the base year of $8. That gives us 2.5 times 100 gives us 250. So the price index in the base year was 100. In 2002 was 175. In 2003 it was 250. All right. So based on that, we can figure out the inflation rate. The inflation rate from 2001 to 2002 was 75%. We went from 100 to 175. You see the percent change formula there, right? So 175 minus 100 divided by 100, 75%. The inflation rate going from 2002 to 2003, okay, was 250. The price index for 2003 was 250 minus the price index in 2002 of 175. Which gives you, I don't even know what that is offhand. That'd be what, 75? All right. So 75 divided by 175 gives you 0.43, so 43%. All right, was the inflation rate from 2002 into 2003. All right. So this is how we work it. This is how we figure out what the inflation rate is. All right. Oh, here again, another example. Base year is 2002, blah, 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 right? So you get an idea of how this is operating here. We can figure out what the inflation rates are and using these price indexes. All right, what's in the CPI's basket? This is just a little pie chart showing you various things that are in there. You have to take notes over this. It's just for informative purposes. This isn't something they ask you. What you need to know about CPI is that it is a price index that analyzes the goods and services that a typical consumer buys, a typical urban consumer buys. All right. There are other price indexes out there. Again, this is the CPI, and it's one of the more popular ones that is used and analyzed. Typically, if you hear on TV or on the news and they say, inflation was such and such percent, typically what they're talking about is inflation using the CPI, all right, as opposed to other price indexes out there. Official stats guys don't always use this, like the Federal Reserve doesn't use CPI. They use a different one. I can't remember what it is offhand, but they consider that one to be more accurate than CPI. All right. Now, problems using this and using the CPI to measure cost of living. Typically it's going to be all right, but there are some drawbacks. One of them is what's called the substitution bias. Another one's introduction of new goods, and the third one's unmeasured quality changes. Okay, with the substitution bias, what happens here is because they don't change things all that often, what could wind up happening is that a substitute is introduced for a product that is already in the CPI, and consumers are actually buying the cheaper substitute. They're no longer buying the previous primary good that's now more expensive. They have shifted to buy the cheaper substitute. Now what this means is that the CPI is overestimating the cost of inflation to the standard of living. All right, so they're making things seem, CPI is going to make things seem worse than what it actually is, because it's not measuring the fact that people are actually buying the cheaper substitute, and therefore their money is going further than what the CPI makes it seem. All right, so we can actually overestimate inflation. All right, so that's the substitution bias. Very good. Introduction of new goods. This is the fact that CPI doesn't throw in new things that people are buying very quickly. All right, it has to be something that people tend to buy for a longer period of time before it's included, or other stuff gets excluded so the new stuff can be thrown in. All right, so if consumers are buying new things that are out there that just flat out didn't exist before, maybe it was smartphones at one point, maybe it was PCs at one point, or 3D printers or something. All right, so those things that consumers might be buying, but that is not included in the CPI because it's a new thing, and if you include too much new stuff, then again, CPI is not going to be good for comparison purposes. All right, you got to keep the market basket relatively constant. So if the new goods are good and is increasing variety and standard of living, again, CPI will seem to be overstating how much inflation is hurting people's standard of living and what they're being able to buy, because they're actually buying newer, better goods than what they were before. And then finally, unmeasured quality changes. What the problem here is that goods may improve over time, and that improvement means that you're actually getting more for your money, but that isn't calculated by the CPI. The CPI is only looking at the money that is being spent overall. So let's say you're talking about iPhones. Let's say that over a 5-year period, Apple never changes the price of the iPhone. Let's say that over a 5-year period, the iPhone is $1,000, right? So it was $1,000 starting in 2015, and it was $1,000 all the way through 2020, all right? I know there are changes, but let's just say there was $1,000 for iPhones all the way through, whatever the newest iPhone was. All right. Now, the newest iPhone in each one of those years was better than the previous version, right? So the $1,000 is actually buying you a better product in each one of those years, which means that your money is going further because of the increased quality of the product of the iPhone in each one of those years. But the CPI won't recognize that increased quality. All it's going to look at is the iPhone costs $1,000 here, and it costs $1,000 here, and $1,000 here, and $1,000 here, right? So it doesn't take into account quality improves, and improved quality means that your money is actually buying you more than what it was previously. So again, CPI would overstate just how much inflation can be cutting into standard of living, because it doesn't calculate in quality differences and quality changes, quality improvements from one year to another one. All right. So those are the big ones. Right. This is an old PowerPoint, but it'll serve the purpose here. GDP deflator is a different type of price index, but it's just a price index like any other one. Okay, the difference with the GDP deflator is that instead of looking at just a select number of goods that are purchased by the average urban consumer, GDP deflator looks at everything that's being produced in the economy. Okay, so this is what's called the GDP deflator, right? It's looking at all the goods and services the economy is producing, and therefore all the prices, basically. So it's just a price index, though. So the deflator is calculated as followed, right? Nominal GDP over real GDP times 100. Okay, but really this is just another way of looking at it as being, the same calculation as what we saw before, CPI. All right, so what's the price index? Well, it's nominal GDP, the market basket in your comparison year. It's just the market basket includes everything, divided by the market basket in your base year. That'd be the real GDP times 100. All right. Now, the important things to know about GDP deflator is A, it includes everything that's being produced in the economy instead of some stuff, and this equation right here. Typically, any sort of questions that they want you to use this equation, it's just solving for x, right? So they'll give you 2 out of the 3 parts and ask you for the remaining 1. So it'll say the GDP deflator in such and such year was this, the real GDP was this, what was the nominal GDP? Well, if you know what the deflator is, you know what the real GDP is, right, then you can figure out the nominal GDP, right? So you've gotten 2 out of the 3 variables within the question. It's just solving for x, it's simple algebra by that point, right? Or they'll give you the deflator and nominal GDP and ask you to find the real GDP. So you're just trying to find that x in the denominator, right? So it's relatively easy to do. Again, you can't use a calculator on the actual AP macro test, so therefore they keep the math relatively simple. It's something you can usually solve in your head or with paper and pencil. Okay. So BLS calculates other price indexes, but we don't care about those, like the PPI, we don't care. Right? The 2 big ones that AP Macro is concerned with is the CPI, Consumer Price Index, as well as the GDP deflator. So know the equations there, know what it is that they're including in it, and you're golden at that point. All right. Oh, yes. I'm just kind of blow through this right here. You can pay attention to it if you want to. Pause whenever you feel like it, but it's not something that's overly important for our purposes, and this has already gone on for 27 minutes now, so I want to finish up. Oh, yes. GDP deflator, this shows that CPI and GDP deflator kind of move in the same directions, but you'll notice there are differences between the two. But the peaks and valleys are typically hitting at the same point. Oh, yeah. But anyway, you can figure out how much stuff is worth at different times. This is an older one chart here. There have been a few changes with this. This just shows you the top grossing movies over time based on inflation. All right. So what the unadjusted gross was, what it cost at the time compared to if you were to adjust for inflation. All right, so Gone with the Wind has made $1.7 billion over the years. 1939 movie. Indexation, if you say something is indexed for inflation, or sometimes this will be termed as a cost of living adjustment, which will sometimes be abbreviated COLA, right? C-O-L-A, cost of living adjustment. If something is indexed to inflation, or if there's a COLA to attach to it, what that means is that it adjusts with inflation. So let's say that you sign a contract for a job, taking a job, and that contract is indexed to inflation, right? It has a cost of living adjustment clause. So the starting salary your first year is $100,000, right? But it's indexed to inflation, and it's a 10-year contract. I don't know. What that means is that as inflation changes, the salary will automatically move along with inflation. So let's say you start off with $100,000 and 5% inflation happens from the year you got hired to the following year. Well, 5% inflation, that would mean you would get paid $105,000 the next year. All right, so you're getting paid the same number of dollars. What we say nominal dollars have increased, all right? What dollars are worth in that year? Nominal dollars have increased. The number of dollars, you went from 100,000 to 105,000. But in terms of real value, your real wages stayed the same, all right? Because the $105,000 in the following year has the same buying power that $100,000 did previously. So in real terms, you got paid the same, right? So your nominal wages went up, your real wages held constant because they adjusted with what was happening inflation, what was happening with inflation, because of the indexation or the COLA. All right. And one last thing to talk about here is real interest rate versus nominal rates. Okay. Real interest rates are going to be the real rates of return. Think of a nominal interest rate as being the rate at which you take out a loan. So it's the actual percentage at which you take out a loan, that interest rate, or by which you save money. So the nominal rate is the percentage rate that shows you the number of dollars that you're going to pay back or you'll get for your savings. Okay. However, the nominal rate is not actually what you're really paying back in the course of a loan. Okay, that's not the real interest rate. All right. The real interest rate takes into account the inflation. Because if you think about it, let's say you borrow money in 1 year and inflation happens over the course of that year. What that means is the following year, you're paying back cheaper dollars than you initially borrowed. Right? So let's say that 10% inflation happened from 1 year to the next. You're paying back dollars that are worth 10% less than what they were previously. All right. So less valuable dollars. What that means is the real rate of return that is getting paid back to the bank is less than what the nominal rate initially was. All right. So here's the example. We borrowed $1,000 from 1 year. Nominal interest rate was 15%. During the year, inflation was 10%. So the real interest rate is the nominal interest rate minus the rate of inflation. Okay, so R is equal to lowercase I, which is nominal rate, percent rate, minus the inflation rate. So in this case, it is 15 minus 10. The real rate of return, or that you're paying back, is 5%. So as far as the number of dollars goes, you're paying back at that nominal rate. Right, so 15% of 1,000 would be $150. So eventually they're going to pay back $1,150. All right, but the real value of that money is only a 5% increase over what you borrowed in the previous year. All right, so if the real rate of return is 5%, that $1,150 that you're paying back has the same buying power that $1,050 had when you borrowed the money the previous year. All right, so in terms of real value, you pay back 5% value, not 150 or a 15% real value. All right. So what this means also is that banks will always set their nominal interest rates over what they expect the rate of inflation to be. So if the bank expects 10% inflation, then they're going to set their nominal rates for loans over 10%. All right. This further means that this is expected. It's not necessarily what will happen. Okay, so let's say in this case right here, the bank expected 10% inflation, so they set their nominal rate at 15%. They could have gotten it wrong. All right, maybe actual inflation was 3%, which means that, hey, they came out great because they were still charging 15% interest, but inflation was only 3% instead of 10%, which means the real return they were getting back was higher than what they initially expected. All right. Or let's say that inflation was a whole lot worse. Let's say inflation was 25%. All right, things got bad. So the nominal rate was 15% because they expected inflation to be 10%. Actual inflation was 25%. So what that means is that they actually lost value. So they charged 15% nominal rate, but because of the 25% inflation, they actually got paid back 10% less value than what they initially loaned out. All right. So the real rate of return would have been negative 10%, right? 15 minus 25. So negative 10. So they got paid back 10% less than what they initially loaned out. So sucks if you're the lender. It's great if you're the borrower, which means unexpected inflation always helps borrowers. little tidbit there. Unexpected inflation always helps the borrowers, always hurts the creditor, the person who loaned out the money. All right. So summary, blah, 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 everything we just talked about, all that stuff, etc., etc. You can pause and read. It's everything we just mentioned. Yes. There. Good. Done. Have a lovely day. And if you got questions, please let me know, especially for those of you who are remote at home. Ask questions if you got them. All right. If you need a Zoom, we can do that.